We are seeing it now.
My presentation. Yes, yes. We have. I have some problems here, but now it's start. Okay, this is my presentation. It's an outcome of the Transact project. Here, the main goal is a transformation from standalone systems to edge cloud-based systems, and in our use case is the maritime use case. We want to develop an ML-based autoroute for vessels. Today, before Transact, these routes are manual planned with a nav station or an actis, and on shore or on the vessel themselves, and then they can send this route via a nav box to the vessel, and the navigator on board sees this route and can check this route for safety in the active system. You can see this on the right side. Maritime routes are the shortest one is a Great Circle route. This is a red line here. It's well known before Columbus, and of course, when they're on the Great Cycle route is bad weather conditions, we have alternate routes today, but they all are planned manual with nav station on active system. So in the Transact project, our idea was that the navigator requests a route from the nav station via advisory requests response management to the route processor, and then the route processor creates an ML-based route and send it back to the navigator. And sorry, and the navigator had to check this route. Of course, this route must be conditioned to the own vessel. So it was the idea that the auto route is a short distance between two ports, and it's generally safe from a navigational point of view. The ML-based auto route suggestions are based on an analysis of historical and real-time IIS data from our partner NAVTOR. So this solution is a CPS, but the human is responsible at last. So the main research is to develop and test this autoroute. And the challenges are definition of representative scenarios, qualification of test cases, coverage, of course, and representativeness and statistical arguments for overall functional correctness. So the idea was to develop a simulation frame in which we not use real vehicles, of course vessels, and of course this test will not be done in the real world, but in the simulation world. And therefore we need a ground truth from the real world and put them in a database for creating scenarios for vessels between two ports, and we need an abstraction from the real vehicle as system under test. And so we create two reference routes to compare them with the auto route of NAVTOR. And these two routes are one route of a specific ship and one route that is the most frequently sailed one. So, and of course, the question is, what are the ships, what are the harbors they are sailing between? And therefore, we do a statistical analysis, and there we look for all oil, grain, iron ore, cruise, ro-ro, and container routes to see where are the ships are sailing. Of course, we have millions of routes, and we cannot test all routes, of course, and we have millions of ships. And so we look in the statistical analysis for the important maritime shipping lanes that are straits between some ports, and these straits, for example, are Bosporus Strait or Strait of Dover, Gibraltar Strait, or Malacca Strait. A lot of straits are included in these routes, and of course we have a lot of ships and types of ships, and so we look in the statistical analysis for Aframax, Handymax, Suezmax, and very large crude containers to include them in the routes. And also, at last we find 85 coal routes and, for example, 152 crude oil routes, gain routes, and so on. So you see here all the routes from specified vessels between two ports. And we have negative tests. These tests include routes that should not be calculated from the auto route algorithm from NAVTOR, because the specified ship cannot sail this route due to higher draught, and there will happen a grounding in practice. So at last, from the millions of routes, we create 410 routes between two ports for our simulation in the vertical world. Each route starts and ends at a definite port, and each route is served by a given whistle. Statistically, these routes cover the most frequently traveled routes on average. So, yes, what is the idea of this statistical analysis? We want to have a high representativeness of the real world through diversity. Diversity, different ports, different routes, different ships classes. So the implementation of this, our simulation framework, is the real ZUT was the e-navigation suite from NAVTOR, which I have shown in one of the first slides. And we don't use the whole navigation suite, but we use the result of the auto route calculation. In that is the abstraction between the real world and the vertical world. We only use the result of the auto route calculation, and this is this result we compare with the reference route. And of course, we don't sail with real ships between these two ports. Right? That is not necessary, and we use the behavior of ships, the name of ships, and we create simulated routes between these two ports. The ground truth data we use are the here 386 routes or 410. It's now today, and this ground truth data were labeled. Of course, they are based on RES data from historical RES data or real-time RES data. This data are not the data that are used by NAVTOR. This data are special data outside the NAVTOR data from free available RES data. I've shown this later on. This data and build the routes, and we put them in the scenario database to give them in the vertical world. That is our Haggis simulator. And of course, we have critical analysis, we have critical indicators that can be grounding for ships if the draught is too high or there are different obstacles on the route. And of course, for the creation of the auto route from NAVTOR, we have a requirement database for generated this requirements for the routes. So, and of course, we have done a navigational safety analysis in our research. We only use RES data, and NAVTOR for the auto route also only use only use RES data. We don't use radar data, and so we have no fusion. And all calculations depends on one sensor. That is, of course, a small problem. Okay, to develop the two reference route, one reference route for a special ship and one reference route of the most sailed routes between two harbors. That was the main work to generate these two reference routes for comparing them with an NAVTOR auto route. There we have a lot of raw RES data freely available, or we have bought them. And of course, we must look for the region of interest that can be only from one port to another port. And of course, this RES data we had to decoding to get clear RES frames. We've put them in the data processing to see where the ships are sailing, most sailing and special ships are sailing. Then we normalize them, this data, filtered them, and we find two routes for comparing with the auto route. The RES data looks like this. This data includes static and dynamic information. And here you see some of the RES sources we have used. And of course, at first, we had to look from the whole regions between in the world to a special validity domain. Of course, these are the two ports where the route for the vessels have been found. And in our decision for the reference route, we had to look which data had to be clustered, which data had to be displayed and storage, and in some cases we use also machine learning. And the idea of the reference routes are we use different mathematic models, some of them which overlap. By using different models, a high confidence level of the reference route is achieved. We want to have trustworthiness for the reference route. And here's a short look why we have done this, or how we have done this reference route. We have the different IS databases. These include dynamic and statical data. We combine them. We clean this data. Of course, the MMSI, this is a Maritime Mobile Service Identity. This is the identity for one ship's, and this identity is only one time present in the data, we hope, yes. And of course, we had a lot of outliers in this data, and we had to detect them and filter them to find at least the ship types, the ship size, speed over ground, and course over ground. So in the processing, the most three items are the trajectory separation, time interval standardization, and the data cleaning. So for some examples, I shortly show this. It's for a very different process. Here, this is a MMSI validation of in theoretical, there is only one MMSI in all over the world, but we found in a lot of IS data that there are a lot of the same MMSIs for different ships. And so we had to clean this and to find out what are double MMSI numbers. And the results is here shown on the right side of this picture. Here was the right ship. It's only one ship that sails between the Netherlands and Norway, and not here all over this route. And as you see, here are two examples for original ship trajectories. You see, this vessel never has sailed this route. That is not possible. That is not correct. And so we had to filter them out. We had to reduce the noise, the outliers, and missing values. Here on the right side, you see an example. Here are the tracks of one vessel, and suddenly there was a great gap between this data. So it very often is that there are outliers and missing data. So as shown here on the left side, here is a track in the blue dots, and one track was here. The data was here, and then it starts again in this side. So that mostly that is not correct, and we had to optimize this positions, and the real track then is like this one. So in the AIS data, we had also a lot of duplicate data, and as we see before, out of range values. So at last, from the whole processing, we must as a result, we must see IIS data that from the static and dynamic IIS data corresponds to each other. And then it can be used for the reference data. Yes, we have seen this in shortly, this data processing, right, from our AIS database, where we do the processing. We get ship trajectory points, right, which we track by MMSI. Right, we delete duplicates and missing values and organize the trajectory by datetime so that we come to a single ship track like this one. Yes, and for the most sailed route, we also had to for the development of the waypoints, we have to sample all the tracks between two ports for the most sailed route, and then we must visualize them, collect and visualization. And this is done by this process at the DB scan algorithms to compare all the routes between the two ports and to find out the most sailed one. This looks like this. Here are the visualization of some routes between some ports. So together, after the data cleaning and the course variance analysis, we see the vessel's tracks, and in the clustering of the DB scan algorithms, we find out which of the tracks are compared together to get the most sailed reference route. Yeah, and on this slide, here's a short look of the most used models for generating the reference route for one ship and the most sailed reference route. And in the first test slide, first test cycle, we put these routes in our scenario database from port 1 to port 2, and we compare them with the result of the auto route from NAVTOR. Right? So, and in this first test cycle, we test, of course, the requirements for the generating of the auto route from NAVTOR. We test the advisory service, the time behavior. Is the NAVTOR auto route the shortest route? And we test blocker, which are used to get a high navigational safety and test this blocker if they are correct. That are the verifications elements, and in the validation we look at the navigational safety of the NAVTOR auto route, and that we can only do where we have paper chart or electronic navigational charts. So that is the first one. And to get increasing the representativeness of the virtual world, we do negative test cases, and we try to interrupt the internet connection during the auto route calculation and see what is happened in the A navigational suite of NAVTOR. And also, so as I told before, we have negative test cases. So one example of the routes here. Here is a container auto route from Busan to Taichung, and with this ship, Harmonized Earth, is simulated, and the distance of the outer route calculation from NAVTOR is 796 nautical miles, and the duration of this voyage is 2 days, 8 hours, and 49 minutes. When the vessel, Harmonized Earth, is planned this route with 40 knots. So, and yeah, the reference route of this Harmonized Earth between these ports that have a length from 829, and this is the reference route, our reference route for the comparison with the NAVTOR auto route. So you see, it's a straight line that is sailing by this vessel based on historical and real-time IAS. And this route, the reference route, is from the Harmonized Earth is longer than the auto route from NAVTOR. So, and the most sailed route between these ports is this one, and you see for the different models we have used, it's a very straight line between this port and this has a long part. This route is about 799 nautical miles. So the NAVTOR auto route is the shortest route between these two ports, and it's principally navigational safe. Yeah, as a second one is a complex route between Hong Kong and Beirut. The ship is Olivia, and the planned speed is 11.5 knots, and the reference route we have generated is shown in this picture here below, and this reference route has a length of 6,750 nautical miles, and as you see here, this reference route is longer than the calculated auto route from NAVTOR. And the most sailed route between these two ports is this one here. That is a green line, is a reference route, and the blue and yellow dots are ships that's sailing around or on this route also. Yes, and also you can see from the used models for creating the most sailed reference route, it was a very straight route. That is one result of this of the used models. So in this first test loop, we see that the NAVTOR auto route at first, in the first versions, does not include any weather forecast, but now it included, and also it does not include depth informations for the vessel, but now it also includes this in the new versions. And in the most cases, from the nearly 400 scenarios, the NAVTOR auto route is in most cases shorter than the specified reference route of one ship, but in cases it is longer than the most sailed reference route between the two ports. Yes, and this is due to the most sailed route where are ships with lower draught are included, and these ships can sail shortly under land or shore, if you like. So, and also we found that the advisory service from the NAVTOR auto route generation works stable, and the blockers to reliable and is reliable and navigational sensible and works perfectly. In the second test route, we want to test also in the validation items all routes automatically by our simulator here called Haggis. And this was the second test case. Here we want to say automatically the navigational safety of the NAVTOR auto route worldwide. And the challenges are automating the driving of many routes in a row so that we can start this test in the morning, and in the next week we have all results. And of course we want to implement a replanning of routes that are inside by environments. When there is a bad weather conditions, we want to get or to generate a new route for the vessel. Yes, and I think this is the end of my presentation.
Thank you, Dr. Eckermann. Wonderful presentation. Yeah, that's very nice to get to know about NAVTOR. And yeah, floor is open for any questions from anyone, audience.
Yes, I have a question. My name is Mihali Marco from the Technical University of Cluj-Napoca, Romania. And I think I heard you say you use DB-scan in order to find the most common route. And I wanted to ask if the result of DB-scan is like a single route, like a time series, or is it like an area or a route with a confidence interval?
Yes, it's yeah, the most sailed route. So as I show in you see that as the outcomes, you see it's like a corridor, and if there are a lot smaller ships included in this route, in the most sailed routes, this route goes near the land, near the shore here, Italy. There are included a lot of ships in the most sailed route. In some cases, hundreds of ships.
Good. Any more question?